All right, welcome everybody to our session. It's not a best practice if no one can follow it, learning from our container security mistakes. I'm John Morello. I'm the CTO and co-founder of Minimus. Previously, I did the same thing at Twistlock, which you guys might remember. So we have a long history in container security going back, I guess, when you could say it kind of all started about 10 years ago. And Alex?
Hi, I'm Alex Zenla, the CTO of Edera. I have only been in cloud native for like a year or something. Previously, I worked in the IoT industry on different various things for the last 12 years. And I am very interested in security because of the lack of security in IoT.
So we'll start off with just a little bit of, I guess, of retrospection about where things are coming from, where we've been, talk about some of the things that we saw over these past 10 years, and then what are some of the remaining, if not problems, at least things that are still problematic for people, and some of the opportunities to improve on those. So of course, we have a meme about that. But if you take your time machine back to 2016 or even 2015 when we started Twistlock, that was the dawn of this new age of computing, which at this point I think is kind of just like normal computing. I mean, we're all here at KubeCon, of course, so nobody thinks anything's particularly interesting or cool about the fact that you're running your application on containers and Kubernetes anymore. And that's a good thing, right? It means that everybody's using that. It's just sort of a normal, natural part of the way that you operate modern applications. But if you think back 10 years ago, that was a quite different thing. Like through my own career, there have been a number of generations of computing, starting, you had the kind of client server days and virtualization, as it were, and then cloud, and then, cloud native. And I guess today you could talk about everything becoming very AI focused. But at the beginning of this cloud native world, people really didn't have a good grasp about the best ways to develop and operate and really to secure this new set of technologies. With everything else in computing, computing is always about layers of abstraction over previous layers of abstraction. And that always makes security in many cases more difficult because there's more channels, there's more things that you have to consider when you want to think about how do you secure the entire stack when that stack is continuously built on more and more stuff. There's more and more dependencies that are there. So one of the challenges that people had in those days really was the fact that the tooling that was built for that prior era really wasn't, first of all, just technically aware of containers. Like if you go back to 2015, one of the first things that we built at Twistlock, like literally the first part of the product we were shipped, was just a very basic RBAC proxy, so that you didn't have to say like, oh, if somebody wants to run containers, they have to be root on the machine, which was literally how it was in 2015, which seems kind of crazy today. But how most technologies start, security unfortunately is not the first thing that people focus on. In fact, it's actually one of the last things a lot of times that people think of. And at the same time, even understanding what your risk posture was. If I have a container image that I've pulled from Docker Hub or wherever I might have gotten it, is this thing safe for me to use from a very minimal standpoint of just like, does it have a bunch of vulnerabilities? And just being able to see inside of that, to be able to see through the layers, to be able to figure out like what vulnerabilities exist, that was something that was very difficult. Further, when you were operating and running these entities, this was coming from a world where the cloud was still basically a bunch of EC2 or whatever the provider was, virtual machines. Where the notion of protecting network traffic was a lot more clear. You had these virtual networks that existed. You had host-based firewalls. People were generally familiar with that technology and had been using that kind of technology for at that point 20 years, arguably. Well, when everything again is abstracted into these container network namespaces and the connectivity there is provided, not at the host level, a lot of the tools just didn't know how to support that. And of course, over those next 5 years or whatever that we ran Twistlock until we sold that, and there's been a lot of other consolidation in that space. Obviously, those tool gaps have been filled for the most part, right? That's why Twistlock existed, and Aquasec and all the other various players. And if you guys use Wiz and Orca and all the things that are in vogue today, but there's still some operational challenges that exist, and that's what Alex is going to help talk about solving. A funny little aside, and this is a real thing because I remember getting this. During those early days of Twistlock, we used to get a lot of inquiries from like the port of Abu Dhabi and such places that would be like, "Kind sir, please give me a quote for 10,000 Twistlocks." And we'd be like, "I don't think we have the kind of Twistlocks that you're looking for." But it actually happened enough that I had a canned email that I would send to people that would explain that because it was so frequent. So it just shows you how even when you have a website with plenty of data that you spent God knows how much money and time on, people still don't necessarily look at it at all. So what were some of the early solutions? Obviously Twistlock being one of those around doing the vulnerability scanning, the microsegmentation, the runtime defense, and so forth. We did, and then also like from a community and more infrastructure layer, Alpine, and there's other players and other technologies of a similar kind of bent. You guys might use Debian Slim, generally same kind of concept with that as well. Of course, there were various other things like Red Hat had or has, I guess, UBI. But the notion of saying like, hey, if we're going to run and build applications that are going to be containerized, we probably don't need a full-blown operating system with all the stuff that goes along with that and all thus the vulnerabilities that pulls in. If we started with something more minimalistic, could we help developers and help everybody ultimately get to a lower risk profile by just not having so much stuff to deal with? And so Alpine was a first step to that. Our current company, Minimus, we're really doing the same, kind of the modern version of that, building everything directly from source on a distroless base layer. But just another example of how like all those general security principles are still valid even years later. So if you think about like what that looked like 10 years ago, there was generally this notion that I think Docker was the one that really talked about this or introduced this kind of concept the most, build, ship, and run. There's kind of different phases to the life cycle of an application that you're running in a cloud native form. Building, again, if you can lower the risk by simply not having extraneous unnecessary components, you're using Alpine in those days, or maybe you're using something again like Minimus today, so that you just simply don't have all those components that bring in those vulnerabilities and those risks. Shipping, how do you make sure that what you are actually delivering to your customer or to your internal audience meets your security requirements? So you guys, I'm sure, are familiar with tools like Trivy and Gripe today that you might use to scan a container image for vulnerabilities. The ability to do that, though, not just as a standalone, but to do that as part of your CI pipeline is really critical because, back again in those days, that was a very innovative idea to say that every time I was building the runtime artifact that I was going to actually execute in my environment, that I could actually look for vulnerabilities in that prior to deploying it was really a fundamentally different approach that was not realistically possible for most people before from a security standpoint. Today, that's something that hopefully everybody considers just to be a normal part of how you operate. I would hope that most of you guys, as you deploy applications on Kubernetes, if not doing it just in the CI process, maybe even doing it with admission controllers and other technologies that allow you to really have a much better gatekeeping ability before you actually deploy something. And then of course at runtime, that ability to look for anomalies at runtime, not just process activity, but to really be able to segment and control traffic flows between these different entities. Like with everything else, again, with computing, as you have new technologies, some things become easier and some things become harder. It's very relatively, I would say, easy today to have very sophisticated inter-application connectivity. If you think about all the tooling that exists to facilitate that connectivity today, there's lots of tools that make it easy to discover things, etcd and so forth. But there's also just a lot of tools that make it easy to make those connections between systems. However, at the same time, that is largely abstracted from you as a user. You just deploy something and it kind of like automatically works. Well, if you don't really understand what those flows are, it becomes a lot more difficult to secure them. So Alex is going to talk a little bit about how you can do that today. We also want to make sure this was more interactive too. So, just maybe a show of hands to begin with. How many of you guys would say like the things we've talked about before, up to this point, scanning before deployment, ensuring that you've got controls prior to actually getting something deployed, and some degree of runtime defense, network security controls within that containerized environment. How many of you guys would say that you're using all three of those today in a meaningful way? So it looks like about maybe 2/3 of the audience is doing that already. Out of those guys that raised their hands and said that you're doing it, how many of you would say that you have a generally, let's say, harmonious or happy relationship with the way that you've done it so far? A lot fewer hands. One and a half hands back there. So clearly there's a lot more that I think as an industry, as a community, we can all do to not just like have the basic capabilities be technically capable, but to really make them something that is viable for people to adopt and to use, and to really get the security benefits they need from that. If you kind of distill down what these problems still are, again, today it is very possible for you to utilize a variety of techniques to minimize what goes into your container images, right? You can build images on a distroless base that have a lot less components that are included in that. But that, a lot of organizations, it's very difficult to do that at scale. It's very hard to manage that at scale. Similarly, there's a lot of controls and open source projects that focus on some degree of microsegmentation or container native connectivity between components that are there. The fact that that is theoretically possible doesn't mean that it's something that's actually adoptable and usable by people. And so that's really what we want to focus on, is how can you make some of those things more usable?
Awesome. So now I'm going to talk about how we solve these problems. The most important thing to remember, and we stuck this meme in here to help you remember, is that containers are not a security boundary. They were never really designed to do what we're doing with them. There is no container concept in the Linux kernel. It is a collection of concepts that are built together into what you think of as a container today. We've built container runtimes here at Edera, and I can tell you that it's not easy. So what's important here to understand is that the way that people defined container security in the past was all about detecting vulnerabilities and maybe some level of prevention of like preventing a system call that's rogue from hitting an application, hitting the host system. But what's really important to understand with that is that today we need to manage the security of a container or an application across its entire life cycle. Not just at the vulnerability scanning level, not just at the runtime level, but really thinking about how holistically we manage these systems. And that represents a paradigm shift today. So that's going from detection to prevention, from alert generation to alert elimination, from post-breach response to pre-breach containment, and reactive compliance to proactive security by design. Your tool should be helping you solve these problems and being proactive and actually bringing you solutions and not problems for you to solve. In our last session, we were just talking about how a lot of security tools are all about giving you a big checklist of things to fix. We have to fix the foundations of our technology in order to support what you are trying to do with your applications today. So what does this look like? It means bringing not just minimal operating systems, but distroless containers. Instead of doing CVE scans or just CVE scans, making hardened CVE-free images so that you don't even have a CVE that you need to scan out of it. And then in-cluster microsegmentation in the past can now be hardened runtime with isolation. So it's building your container runtime so that it's not just a C group and a namespace in the Linux kernel, but truly something that is actually meant to be a container from the lowest level on. And what does that mean with hardened runtime? It's multi-tenant isolation that's putting actual sandboxes around and between your workloads so that they can actually be protected and actually ensure that you actually can trust the security of your system. And that's eliminating attack surface, like your trusted computing base. That's the amount of code that's reachable that can actually run at runtime. If we can reduce that trusted computing base, then we can decrease the possibility of an attack even being possible. And then when things do go wrong, we have real-time containment. That means quarantining or a kill switch capability so that you can actually take a vulnerability that occurred and inspect what happened, but also ensure that it does not make any sort of security sensitive decision or contact the network. Security can't be a series of stoplights. Maintenance is just as important as easy integration. So that means that it's all well and good to say that something is easy to install, but what's the life cycle of managing that tool? Does it help you? Is it hurting you? Visibility can't cause paralysis. We've talked with people who have all sorts of alerting systems and observability systems that have massive influxes of logs. And sure, that's really good for when something goes wrong, but what happens when you want to just understand that the security of your system is good from the outset? You have to pour through all of those logs, and it's really difficult to handle. And security should work with developers to keep moving forward. There's a huge problem right now in the industry where security is really all about kind of giving a big checklist of problems, but also there's like an antagonistic relationship between security and developers, especially with the rise of AI-generated code today. We need to fix that problem by making security kind of work for the developers, and the developers understand that the security is by nature something that needs to be solved. Especially with AI, I'm personally terrified of what's going to happen the more AI-generated code gets deployed into production. And security should shape the road. It can't just replace the technologies with a big, beautiful island. You need to have a real bridge for adoption. I talk about internally at Edera a lot about how we build things that are actually easy to consume in platforms today versus something that you have to go build your application directly for it. Allow people to take their existing application and make it more secure by having a better foundation. And we need to redefine that security and dev intersection and make them like each other again. And if you remember nothing else from this talk, it's very important to understand that easy to deploy does not mean easy to maintain. Just because you can deploy it does not mean that the maintenance over time is going to be worth it. There's a lot of tools today that get deployed and then basically immediately removed the first time someone has to touch it. Baking security in from the start is a lot easier than bolting it on later. If we give you the right secure foundations, us as people who are working on the infrastructure level, we don't have to have you have a big checklist. We can give you a smaller checklist of little things that are specific to your application, but not just holistic problems that are generally wrong with the security today. And your deployment doesn't stop with containers. You must work across the entire stack to make things better. We recently, just this morning, released a bootloader. We wrote that bootloader because we need the security and more performance out of bootloaders. Just because it's at the lowest level of the system doesn't mean that you should be afraid to attack it, I think, from a performance or security perspective. And I find that it's really important that we look at all layers of the system to solve these problems. Questions?
Yeah, we wanted to make it an opportunity for really kind of an ask us anything. We're obviously people that have a lot of experience in this space and have seen it grow and change really since the beginning of it. So any kind of questions that you guys might have about past, present, or future, we'd be happy to talk about. If there's no questions, we had some other ideas we'd ask each other even. Go ahead.
So this is my first time really hearing about the term distroless containers. In my head, that sounds like pulling up the sort of bare minimum Linux kernel and enough binaries, but without pulling in like all of Debian Buster or something. Is that
kind of? Yeah, actually, the question basically is effectively what is a distroless container, and not to be too pedantic about it, but I would actually describe it as distroless images. The container is kind of the runtime entity that's created that the software and the image executes within. But like the easiest way to think about it, and the reason I say this term specifically is if you think about it as an image, it makes a lot more sense than as a container. So a distroless image is effectively saying like you're going to have an image that only includes the specific components required to do whatever that image is supposed to do. So like as an example, if you have Nginx, you might only have inside of that image the Nginx binary, and a handful of low-level stuff, like libssl and whatever else. And actually, I'm going to use that as a specific example because it's what I usually show when I introduce people to Minimus, and the differences are really stark when you look at it. So for us, again, our images are effectively distroless. if you look at the official Nginx image, like if you were to pull the latest Nginx image from Docker Hub, which is built on Alpine, it has 230 some odd packages in it, and it's like 70 something megs on disk, okay? To run just Nginx. So if you want to just have a hello world, HTML page that comes up, that's generally what you're looking for. And even right now today, if you were to pull the very latest version of Nginx today, you would get something with like 100 some odd vulnerabilities and like 20 or so like high and criticals. Obviously it changes day to day, but roughly something like that. If you build that from a distroless base, and you do so in a thoughtful, purposeful manner, like you're not going to just kind of cheat and just put a shell in there and then all their dependencies and so forth. You want to actually like think through what's really required. The Minimus version of Nginx has like 15 packages and is like 9 megs on disk. So it's like literally an order of magnitude smaller, and that's how our image we can maintain pretty much continuously at 0 CVEs. At least no more CVEs than exist in the upstream for whatever the given components are. So you might say, okay, well, why would I need to do work with Minimus or anybody else around that? The unfortunate reality is it's actually difficult to, as like an end user, so to speak, for you to think through for every one of the images that you use, what actually needs to be in there and how do you actually build that in a distroless manner, which is why very few projects issue an official image that's distroless. They could, but if you're Nginx, I don't want to speak on their behalf, but anybody basically that's out there, that build team for that community would really have to have a lot of awareness and put in a lot of thought and effort to minimizing what's in there. It's a lot easier for them, to just kind of simply build on something that's got bash and busybox and know that all the shit, scripts and so forth are going to work. And it also is relatively easier from their perspective to support their quote unquote customers, their user community. If I can say like, hey, if you download this image, it's got the debugging tools, the logging tools, like all that stuff. But the reality is, of course, all those things have their dependencies, which have their own dependencies, and it can do third, fourth order dependencies, and that's how you end up with something that's 10x larger. So the value of that we provide for Minimus, and that any sort of provider of such images would do, is being able to do that work at scale to decompose and kind of factor down what are the really required components to run not just one thing, an example, but hundreds and hundreds of different applications, and then to do all the work to engineer that so that it works, and then to maintain that continuously over time. That's really the difficult piece with it. You could easily today or this afternoon, you could make a distroless image for almost anything, but doing that at scale in a manner that's going to work reliably for your developer teams, that's the part that's hard to do.
How are you scanning a distroless container or image and getting a reliable result that's not coming back with a false negative?
That's a great question. So if it's distroless, it doesn't have a package manager, how are you able to scan that and get reliable, accurate results? It's a great question. And actually, going back to like my Twistlock days, that was actually a hard thing for us. We built like literally the original container vulnerability or image vulnerability scanning tools. The answer is, if it's truly distroless, if there is no package manager and there is no kind of metadata repository that describes what packages are in there, it's really, I would say, effectively impossible to do it reliably, because then you're trying to do some kind of binary analysis, which is completely, inconsistent from one thing to the next, or try to do some sort of hashing, which is also just it does not really work at scale. So when I answered the other gentleman's question, I said that our containers, our images are effectively distroless, because what we do is, even though they are a distroless base, we still have a package manager that we use really just to make it easier for us to do exactly those kind of things, to describe what's inside of it, not just for scanners, but for our own internal tooling to know how to build that. And so really the way that it works in our case and other similar sorts of implementations where you have minimalistic base layers, maybe even effectively distroless base layers, is they will still typically have some kind of entry in Etsy OS release that will say, like in our case, this is a Minimus based image. The operating system is really irrelevant. It doesn't change versions or anything, but what that allows a scanner to do is to say, okay, if I see that the provider is Minimus, here's where the secdb feed is for that. I can pull that data down, and then there is some kind of metadata repository. It might just be some kind of JSON or something like that that exists in the image, but there's something that says, here are the components and the versions of the components that exist within this image. And then you can compare, as a scanner, you can compare the contents of that to whatever is listed in that secdb feed, and thus be able to generate reliable vulnerability results. So like that's the way that we do it. That's the way other similar kinds of projects that also try to do like a minimalistic layer do it. Because if it's like truly going back to like the original, Google vision of distroless, where it is literally just completely empty file system to which you copy binaries, you really can't scan it reliably. And actually, I remember when that first came out, I think it was around 2017, it got a lot of interest because, it was backed by Google, and it seems like, as a security person, it seems very desirable. Like, it seems like a great idea. But I think, to me, one of the reasons that truly distroless images never got much traction in the marketplace was because scanners can't do it reliably. So like you literally just didn't know what you even had in those images. And if you're a security team, like, that's not really acceptable, right? You can't just kind of say like, well, I'm using the version of Nginx distroless from last month, and I don't think it has any vulnerabilities. I haven't read about any new vulnerabilities that have come out since then. Like, that's not a way anybody's going to want to operate.
Based on the experience of both, which are the main challenges companies are having trying to adopt a security posture, and what, as a cloud-native industry, we could do about it?
Yeah, I think the biggest problem right now is that containers have all sorts of different ways that you can make them massively insecure. We're talking Docker and Docker. We're talking, dangerous capabilities in containers and things like that. I'm seeing a lot of problems where, especially CI systems, are extremely insecure from the outset. We're seeing a lot of interest in solving those problems by having new container runtimes and new container technologies. So personally, that's what I'm seeing a lot. Also seeing a lot of interest in building out new mechanisms for policies that don't require the manual editing that we used to have to do, but rather are auto-generated and things like that.
Yeah. And I think this is the last question because we're out of time here, but the other thing that I would add to that is I think that one of the challenges that still really has not yet been solved well, but I know Alex and team are, is it's still really difficult, I think, to manage traffic flows within a cloud native environment. You have things like Trafic and so forth, but to me, I feel like most of the tooling for that has been designed more to enable easier traffic flows and less about securing traffic flows and inspecting traffic flows. And that's one of the challenges. Like, if you're coming at this from a security standpoint, when you just kind of have this opaque blob of data that's all encapsulated that you can't see into, that's like now, really the predominant data that you're worried about for the data plane of your application. To me, that's a real decrease in the relative level of visibility and control that you had before.